Imagine embarking on an interstellar journey with no traditional fuel on board. Instead, your spaceship is propelled by the gentle push of light itself, using the momentum carried by photons to generate propulsion. This might sound like something out of science fiction, but the concept of laser-powered starships is gaining serious attention as a potential ticket to the stars. A new kind of journey. The idea is based on a deceptively simple principle: use powerful laser beams to propel a spacecraft equipped with a lightweight sail, much like how wind propels a sailing ship. Unlike wind, however, lasers can maintain a consistent and focused push over vast distances, making them effective for interstellar travel where traditional propulsion methods would quickly lose power. This light sail captures the energy from the laser and uses the momentum to accelerate. Unlike conventional rockets, which are burdened by their fuel mass, a laser-powered starship could theoretically reach astonishing speeds because the energy source remains stationary, far from the ship itself. Breakthrough Starshot, a real-life example. One notable example of this approach is the Breakthrough Starshot initiative, which aims to send tiny, laser-driven probes to our nearest star system, Alpha Centauri. The concept involves ground-based lasers firing at ultralight sails, potentially accelerating them to up to 20% of the speed of light. At such speeds, the journey to Alpha Centauri, which would take tens of thousands of years with today's technology, could be completed in just a few decades. Imagine receiving images and data from a neighboring star system within a human lifetime, a prospect that would have seemed impossible just a few decades ago. The Breakthrough Starshot initiative envisions launching thousands of these tiny probes. Each probe will be equipped with cameras, sensors, and communication devices designed to send data over interstellar distances. These communication systems will rely on highly efficient transmitters and precise laser-based methods to ensure signals can reach Earth from light years away. By sending out a fleet instead of a single spacecraft, scientists hope to increase the chances of success. Even if some probes fail, others may make it, ensuring that valuable data is transmitted back to Earth. This concept highlights the resilience and adaptability needed for interstellar exploration, as well as the potential for collective achievement when many small, relatively inexpensive units are deployed together. The challenges ahead, however, there are challenges aplenty. The lasers need to be immensely powerful, requiring vast amounts of energy and sophisticated aiming systems to keep the beam precisely focused on the sail over vast distances. Any deviation could mean a loss of propulsion and mission failure. In addition to the need for precision, maintaining the coherence of the laser beam over many millions of kilometers presents a significant engineering challenge. Atmospheric disturbances and other environmental factors can disrupt the laser, which means ground-based installations may need adaptive optics, systems that compensate for atmospheric turbulence, or even space-based platforms to ensure the laser remains stable and effective. The sails themselves must be both incredibly lightweight and resilient enough to withstand the intense pressure of the laser beam without being destroyed. They must also be capable of maintaining their structural integrity as they are bombarded with photons at such high intensity. Advances in material science are crucial here, with researchers exploring options such as graphene, which is not only lightweight but also exceptionally strong. The sail's reflective properties must be optimized to maximize thrust while minimizing the risk of overheating or damage from the laser's energy. Navigating the hazards of space. And then there's the issue of navigating through interstellar dust, which could damage the craft traveling at such extreme speeds. Even tiny particles of dust can pose a significant threat when moving at a substantial fraction of the speed of light. A collision with a small piece of debris could potentially destroy the sail or the onboard electronics. Scientists are exploring ways to mitigate these risks, such as incorporating protective shielding or developing evasive maneuvers to dodge larger obstacles. One proposed solution involves using a forward-facing laser to vaporize small dust particles before they impact the craft, effectively creating a protective path through interstellar space. Moreover, communication with a laser-powered starship presents another significant challenge. At distances of several light years, sending signals back to Earth becomes incredibly difficult due to the vast distances involved and the weak power available on such tiny probes. Researchers are investigating ways to use laser beams not only for propulsion but also for communication, allowing data to be transmitted over these immense distances with minimal power. The probes would need to be equipped with highly efficient transmitters and rely on Earth-based receiving stations with advanced optics capable of capturing these faint signals. The promise of laser-powered starships. Yet, despite these challenges, laser-powered starships offer an intriguing possibility for interstellar exploration. They represent a vision of the future where our reach is not limited by the amount of fuel we can carry, but by our ingenuity in harnessing the power of light itself. Imagine a network of laser-powered starships spreading across the galaxy, each carrying sensors and probes, sending back valuable information about distant star systems, planets, and even potential signs of life. This kind of exploration could pave the way for a deeper understanding of our place in the universe. Applications closer to home. The potential applications of this technology go beyond simply exploring other star systems. Laser-powered propulsion could enable rapid travel within our own solar system, allowing us to reach planets and moons in weeks instead of months or years. For example, missions to Mars could be significantly accelerated, enabling quicker human exploration and reducing the risks associated with long-duration space travel. Similarly, this technology could make studying the icy moons of Jupiter, such as Europa, more feasible, potentially advancing our search for extraterrestrial life. This capability could revolutionize space exploration, enabling more frequent missions to study the outer planets, their moons, and even objects in the Kuiper Belt and beyond. The technology could also be adapted for use in planetary defense, providing a means to quickly intercept and study potentially hazardous asteroids. A vision of the future. Perhaps one day, the sight of a shimmering light sail disappearing into the darkness will be humanity's first step towards the stars. It will be a symbol of our determination to explore, to push beyond the boundaries of what we know, and to embrace the challenges of interstellar travel with creativity and perseverance. The dream of reaching other star systems may no longer be confined to the pages of science fiction, but instead, it may become the next giant leap for humankind, a step that will open doors to incredible new discoveries and inspire future generations to look to the stars with hope and wonder. The spirit of exploration. The journey to the stars will not be easy, and there will undoubtedly be setbacks along the way. But the pursuit of such an ambitious goal is what defines us as a species. It is the drive to understand, to explore, and to expand our horizons that has taken us from the first steps on the moon to the edge of our solar system. Laser-powered starships may be the next chapter in this story, a story of curiosity, innovation, and the unyielding desire to know what lies beyond. As we continue to develop the technologies needed for interstellar travel, we are also cultivating a sense of unity, a shared vision that transcends borders and generations, reminding us that we are all part of something much greater. One day, as we watch the light sail accelerate into the cosmos, we may realize that this journey is not just about reaching the stars, it is about understanding who we are and what we are capable of achieving together. The adventure of laser-powered starships is as much about the destination as it is about the spirit of exploration, the courage to face the unknown, and the hope that, somewhere out there, we will find answers to the questions that have driven us for millennia. With each new technological advancement, we move closer to making interstellar dreams a reality, proving that the sky is not the limit, it is just the beginning.